Hello everyone, welcome to Chemazon Complete Chemistry. So in this video we are going to solve some more questions that were asked in NET December 2024 chemistry paper from the part B based on electrocyclic reactions. So two questions in part B were asked from the electrocyclic reactions. So this is the first one. This is a starting material getting converted to the product, and we have to identify the mode, that is whether it happens in presence of light or heat, that is thermal or photochemical. So in the starting material here, if you see what is happening, this 4-membered ring, cyclobutene ring, is getting opened. Okay, so total how many electrons are involved here? So if you see here, there are 2 pi electron and these 2 single bond electrons. So total it is a 4 pi, you can say 4 pi electrocyclic ring opening reaction. Okay, ring is getting opened, so it is called ring opening reaction. Okay, and then how to determine whether it is conrotatory or disrotatory and whether it is happening in presence of heat or light. For that we need to see the stereochemistry. So here if you see, it is trans. Okay, and in the product, if you see, for this double bond, if you find out Ez, it comes out to be E. For this for this side here, you can see this is CH2 carbon, and here it is hydrogen. So carbon gets first priority. For the other groups, here it is carbon, carbon, carbon. This carbon is attached to 3 carbons. This is attached to 2 hydrogen and carbon. Carbon atomic number is greater, so this will get 1. So 1 and 1, higher priority on the opposite side, so it will be E. Okay, similarly for the second double bond also, if you find out, it comes out to be E. So here it is trans, and that trans is becoming, both are same. Okay, so trans is becoming same, that is initially this is different stereochemistry, that is becoming same. That means the stereochemistry is changed. Okay, trans, if it remains Z and E, that is both are different, then we say it is same. Okay, that is stereochemistry did not change. Okay, so that is a trick that you can use. Con refers to change in stereochemistry. Dis, that is disrotatory, refers to don't change. Con, change stereochemistry, and dis means don't change stereochemistry. So here it was trans, it has become same. Okay, so the stereochemistry is changed, so it will be conrotatory, and it is which system? 4n system. Okay, and if you put 1, we will get 4 electrons. 4 conrotatory, it is thermal. Okay, so this table you can remember, you write heat here, heat or triangle, and then light, 4n, 4n2, then you write C, D, DC, conrotatory, disrotatory, disrotatory, conrotatory. Okay, so here there is a change in the stereochemistry. Initially both were different, it became same. Okay, both were E, both became E. So there is change in stereochemistry, 4n, it will be thermal. So the answer is thermal conrotatory. Okay, that is correct answer will be option 4. Okay, so using this same table we have to solve this another question. The HOMO of the intermediate involved in the following reaction. So in the last video we had seen how to draw the HOMO. Okay, for the 5 system that we had not seen, that we will see in this video. So n-butyl lithium is the first step, that is a base. So that will abstract this proton. Okay, this is the acidic proton. Why it is acidic? Because that will be stabilized by cross conjugation with these double bonds. Okay, it is stabilized by resonance. So first thing was to abstract this proton and form this system. Okay, and identify how many pi electrons will be involved. So 1, 2, 3, 4, 5. So total 5 atomic orbital will combine. So this type of HOMO-LUMO diagram you have to draw. Okay, and then total there are how many electron? 2. Here there is lone pair, means 4, and this pi electron 6. So total there are 6 electrons. So you draw the diagram like this. So we had seen as the energy increases, the number of node will increase. Here it is 0, in psi 2 it is 1 node, in 3 it is 2 node, in 4 it is 3 node, and 5 it is 4 nodes. Okay, and how to identify HOMO-LUMO? For that, fill this electron diagrams here. Total there are 6 electrons. So 2, 4, 6, and these are the occupied orbital. The highest occupied is this one, psi 3. So this is going to be the HOMO. Okay, and what is the next reaction? How do you determine this? Because the next reaction is 4n plus 2. Okay, now the question is, here there are two possibility, whether it is the conrotatory or disrotatory, right? So means it is thermal, that is ground state, or photochemical state, because we had seen in the last video that for thermal and photochemical, that is heat and light, in both case HOMO and LUMO are different. So here it is 4n plus 2. So this pi electrons will move here, this pi electrons will move here, here will get a negative charge, and the second step is addition of proton. Okay, so initially this will move here, this pi bond will move here, 1 2 3 4 5, a 5 membered ring will be formed. Okay, so 4 and 5 it becomes a double bond, 1 and 2 a single bond is there, 2 and 3 pi bond is breaking, so it becomes single between 2 and 3, and then 3 and 4 is already a single bond. Okay, and on 3 negative charge will be formed, that will be taken up by proton. Okay, so in this way it is a 4n plus 2 electrocyclic ring closure. Okay, 4n plus 2 electrocyclic ring closure, and here if you see Z and Z, that is same, stereochemistry is same, and here also it is cis. So stereochemistry is same, here also same, product also it is cis, that is same. So it means don't change, don't change means disrotatory. So disrotatory it will be thermal condition, thermal condition means the electron filling will be like this. Okay, if it is light, then one electron will move here, and then this one will become the HOMO. Okay, but here it is heat, so this will remain as HOMO and this one will be LUMO. So this one will be the correct answer with 2 nodes. Okay, the correct answer is option 2. Okay, so I hope you have understood both these questions, how to identify HOMO and LUMO, and the trick whether stereochemistry, how stereochemistry is changing, and how you determine whether it will be thermal or photochemical or conrotatory or disrotatory. We will see in the remaining question in the coming videos. Thank you.